Hello, and this is my video regarding volumes of an object, so calculating the volume of a curve being revolved around an axis. So getting straight into it, we'll start off with the first method being disk method. And I'll just write out the example problem I have, being y equals square root of x minus 1, where y equals 0, x equals 5. And for this one, we'll be revolving it around the x-axis. That's our problem. So firstly, for when we're calculating the volume of an object, you're gonna want to graph it. It helps a lot visualizing what you're calculating. So we'll have a graph like this. And if you remember how to do graphs pretty quickly, you'll already recognize that a square root graph will roughly look about this kind of curve. And we have around the x-axis actually first to visualize. X equals 5. So I think I'll place 5 roughly around here on my graph. And then y just equals 0. However, that isn't our bound. That won't be our bound for our integral because, again, we're on the x-axis, so we have to be doing things with respect to x. So in order to find our other bound, we would take our function and set that equal to 0. And here. And if you're quick and sharp with your algebra stuff, you already see that this will just equal 1. Since, squared, that cancels out. Just move this here. You get x equals 1. That's our other bound, which I'll place roughly around here. And now we see that we have our graph roughly made. So we see our bounds are A, B, but where is our formula really going to come from? So for disk method and any other method where we're finding a volume of an object, we're going to take a cross-sectional area, which will just be our radius pretty much. And as the name suggests for this method, revolving this cross-sectional area will make a disk. And it will look roughly something like this. And we know for the volume of a disk would be equal to the area times the height. And the area for a disk is a cylinder, as it's a cylinder shape. Would be like that. So now, in order to actually integrate this, we would have something like this. Making the area a function of x. However, this would be, since we're looking for the volume, we have to simplify this a little bit more, I meant, into this. Where our radius is now a function of x, since we're looking across a broad term rather than just one specific spot. So this way it's a lot easier to integrate at each and every point that we're looking for. And then we could just interpret the height as just dx. So we'll have dx there. And then taking out our constants to make integrating a bit easier, we're left with this formula for this method. And now we can apply that to our problem. Applying that, we know pi times the integral from our bounds, which we found was 1 and 5, 1 to 5, with our function x minus 1 all squared with dx. And then, squares cancel out, and we're left with pi. Oh, getting a little ahead of myself. our integral looking like this now. And from here, it's just basic integration. You get pi equals times half x squared minus x from 1 to 5. And for timeliness sake, I'll just put in what the answer is already, being, let's see, 16 pi over 2, and then simplifying this would give us 8 pi. And in short, from here all the way up until here, with all of our disks, little disks being added up, we get 8 pi as the volume. And that's essentially it. This even covers for washer method, but we'll see how much more different that is now. So again, I'll just start by getting straight into a problem where we have y is equal to, y squared, I mean, is equal to x. X is equal to 2y without any other information being given other than that we're rotating around the y axis, I mean. So here, this is why even my teacher emphasizes that drawing a graph is extremely helpful for this kind of topic. Personally, me, I like to change these into functions of x just to make recognizing what kind of graph easier. So that one becomes square root of x, and this one would become x divided by 2. And I'll color code it to make it easier to recognize. So my lighter graph will be square root of x, like this. And my darker graph will roughly look like this. Probably not accurate, but gets the job done. And we see here now that it's going to be a little rough to understand the whole, instead of taking the entire volume here, we see that we have two graphs and this spot will be empty because if we visualize the disks we're making, this will be our outer radius. And then this one would be our inner. And we see now that we have an empty space that has to be removed and we're calculating this instead as the volume. If that can be. And this is area that has to be removed. And we can interpret this as our bigger radius subtracting or being subtracted by the smaller radius. And again, we have to have these as functions of x. We're using the same area formula. So our new formula would look something like this. For our outer radius, oops, being subtracted by our inner radius, like so. Now, in this case, we're going to have this in terms of y. Let me remove those. So we'll change these to be in terms of y, respect to y. And that's our formula for this problem. So now we can determine which one will be our inner and outer. We see here, we have our inner, we have our outer. Then we can just, well, no, we can't plug anything in yet because we don't know our bounds. And let me change these as well, actually, speaking of bounds, to be bounds for y term. So moving everything aside, in order to find bounds here, the simplest way is by just setting both functions equal to each other. And then moving things around so that they're both equal to 0. And then we do just basic factoring, kind of just, now we see that y equals 0, y minus 2 equal to 0, will just equal 2. And those are our bounds. And writing them on here will just kind of be like this. So we'd be taking the volume here. So now plugging everything that we know in to the proper areas. If pi times the integral from 0 to 2 for our bigger radius. Now here you use, instead of using the changed one, we actually use the original since it's a function of y. And here we would have our outer radius, so 2y squared minus y squared to dy. And then doing our normal algebra stuff. Our new integral, completed integral, be 4y squared minus y to the fourth. And then from here again, it's just basic average integration, knowing your integration rules. You'll end up with 4 over 3 times y cubed with 1 over 5 times y to the fifth. And then just plugging in numbers, your average integration stuff will get you 16 pi over 15. And that's all. It's not too much to worry about, I feel. I feel disk and washer method go hand in hand. It's the same concept of a disk being rotated up until the curve point. This would just be this method. And if it's washer, that means we have two curves to worry about, with just maybe this visualization kind of working a bit better. That's if I'm on the x-axis. On the y, it looks more like this. And that's all. I hope good luck and have a good day.